Can you see my screen?
Yes.
Okay, cool. So this is the project schema. So basically, we have a data that we're using NIFI to grab it and place it in MySQL. Then I use a really cool tool, Lenses. I'm gonna do a demo on that tool. So basically, it's a DataOps tool that allows us to manage the Kafka cluster. So then I'm using Avro and I'm using a schema registry to shape this schema along with Avro and kind of remove that step from the Spark streaming when we need to manually input the schema. So I use this plugin called APSA for the Avro to make sure that the Spark streaming can process the data. So the Spark streaming will be Spark streaming app will be a call from Levi REST API, and that data will be stored into S3 bucket and also will be connected with Athena and Superset or a simple data dashboard here. So from the Kafka, I also did a sync connector to MongoDB just to save basically absorb the data only like unique for the unique bus ID, and then I built a really simple API that can be used for the app application or for like anything else. So I'm just going to Lenses right now, just show you the interface of Lenses. So this is the DataOps application that allows you to monitor your cluster, Zookeeper, schema registry, and so on. You can also do the SQL, kind of like using SQL to explore your data. For example, I have right now data from the broker. For example, we can use actually you can see the data in real time. You can see the schema, metrics, config, but you can also do the SQL run on it as well. This is a schema registry topology. You can like see how your streams are connected to each other. So right now, I'm going to create a new connector that is going to connect to MySQL, like to basically to this part, to connect it to MySQL here, MySQL. Create new connector, MySQL. Okay, you can see it starts working right away. You can see the reads and writes records right here. So next, what I'm going to do, I'm going to connect it to MongoDB. Right now, I have Mongo running, but it doesn't have any databases or collections. So I'm going to connect to it. So first thing I'm going to create the, there is no database. I'm going to create a new database here. And I'm going to create a first collection / table. And now we have this table available. So now I can connect the Mongo, create a second connection, connections, and now we have a sync here, and we pick Mongo, and place it here. So right now, what I'm doing, as I said, it's absurd only for like from the table status, and I'm doing it basically using primary key bus ID. So it will keep updating the rows related to bus ID. I will show you how it basically works. So the idea of the project is to have this small database that constantly gets the data updated, and it can be served through the API for the end users. Yeah, it should start working. Yeah, Mongo is working right now, I think. So we can basically go back. Now we need to remove that first record that I placed to create a collection. Yeah, the data is already populated here. So I'm going to remove it because it's going to screw the schema later on. Just gonna copy this ID, I'll place it here. Yeah, just delete it. I can come back. Yeah, this is the data. So I have the data populated in right now in Mongo. Now I want to basically run this part of the job to basically trigger the Spark job through Livy. Sorry. I have Livy here already open, like kind of running, and then I'm basically doing from like my local computer right now. So the only thing I need to grab, I need to get the DNS of the AMR cluster. What? Yeah, I have a AMR cluster running, so I copy the DNS and I just change it to Spark. Save it. I'm going to submit the Spark job right now. Okay, the Spark job is running right now, and it should start populating the data in S3 bucket. Yeah, this yeah, should start. Data should start appearing here. Probably takes some time, but I already connected it to Athena and my Athena and Superset. This is the simple like dashboard, shows you the buses and the average speed of all buses running on like route 900. So, and now the last part is on the left of this project is to see the fast API, pull the data from MongoDB, and this is how like the fast API basically looks. And like, let's just get the data, try to run a simple command to pull the data. Yeah, you can see the data is populated here. And from the API part, this basically should start appearing here. So, and like it should be updated every like 30 seconds. probably gonna take some time, but yeah, it's changed. So that's about it. I think I probably cover everything. Yeah. Yeah, and yeah, to improve the project, basically to thinking to put everything on a Kubernetes cluster, like this part, because you can add lenses on any either Kubernetes or MACK on AWS, and yeah, use it. Yeah, and probably just create a small React app to display this data on map, like in real time. But yeah, that's about it. Any questions?
Yeah, it looks amazing, man. This is kind of to the next level. So when you are playing with lenses, and versus Confluent, like did you actually play with both, or just like lenses is kind of something that you think is making more sense? Like you just wanna understand your what is the thinking process of going with lenses versus others?
Yeah, I just read about it, and I really like that it has pre-built lots of connectors already. If you need to add anything new, it's already have I think 25 connectors. So, and also it's robust and it can be scaled, and yeah, it's pretty cool tool. And I like topology. You can actually display your connection, how the data is processed. I really I like the tool compared to others. And yeah, and in the cool part, you can just go to where is it, the topics, right? You have your I think it's I'm using Avro to just Avro to ship the schema, but I think you can also edit it to change to JSON or bytes, binary data, and so on. So it's pretty flexible. I think it's in the schema, I think. If I remember it, I don't remember. No, I think it's yeah. It's I really like this tool. Yeah.
Yeah. This is I mean, this is amazing. And the other thing is I want to comment is using NIFI to hosting your Spark streaming session is super smart. I did not actually think about using NIFI to hosting a session like that, but you just opened another door for me.
Yeah, I just realized that how I can call the a Spark job, not from cluster directly, not logging, but how I can call it from my personal laptop, let's say, right? Not that's was the intention behind it,
Yeah, very cool. And for the super side, when you rendering the data on the on the map, what is the what's the dashboard name for rendering a map? I was thinking about rendering something as well, but
yeah, it's actually, yeah, I can show you. It's the problem with the maps though. Where's the last location? So the problem with the map I'm using, I think it's called Mapbox, but the only thing you would need to get the API from the tool, I forgot what's the name. So they provide you the key for the maps, because by default Superset doesn't have the key, and you just basically need to add as a variable that key, and it will be basically just rendering the map and the dot, the latitude, longitude for the buses or whatever.
Yeah, I mean, yeah, this is top notch done. In terms of end to end, all the features and everything are there, and also it's great that you actually expose more APIs to the end users as well. Good job.
Yeah, thank you. Yeah, and the data gets updated basically once you update the page, it basically gets updated right away too.
Yeah, great.
Thank you.
Thanks, Dan.
Thank you for your help.
I mean, good stuff.